Hey, look at the night sky. What if I told you that some of those points of light aren't just stars, but cracks in the timeline of physics? We call them stellar fossils, and they shouldn't exist. How can a star survive for 13.5 billion years without burning out? Why do they contain chemical signatures that contradict every model of the Big Bang? And if the first stars were supposed to be monsters, how did these tiny survivors get here? I'm going to show you the data that proves our textbooks are missing a chapter. Look at SMS J031300. This star is an anomaly. In a universe where the sun is packed with heavy metals like iron, this star has zero measurable iron. Its iron content is less than 1/10,000,000th of the sun's. According to the core mechanism of stellar evolution, stars this pure must be the second generation ever created, formed directly from the ashes of the very first stars, population 3 giants. But here is the conflict. Current physics says those first stars were massive, up to 300 times the size of our sun, and they should have ended in pair instability supernovae, explosions so violent they spray iron everywhere. But J031300 has no iron. If the first stars exploded the way we thought, this fossil shouldn't have been able to form from clean gas. The revelation? We just discovered a low-energy fallback mechanism. The first stars didn't all explode. Some imploded. They were so massive that their own gravity sucked the heavy iron back into a black hole, ejecting only light elements like carbon and magnesium. This means the early universe wasn't a chaotic firestorm, it was a selective filter. These stellar fossils are the only proof that the first black holes in the universe were born from the theft of the very elements needed to make planets. You aren't just looking at old stars, you're looking at the leftovers of the first black holes. Pretty wild, right?